Okay, the first part of the question is to find the area of R, which I found by finding, well, the first equation is natural log of x, and the second is 5 minus x, and I found out through the graph that the two lines intersect at 3.693. So from 1 to 3.693, we have the integral of natural log of x, and then from 3.693 to 5, we have the the integral of 5 minus x, which equals 2.132 plus 0.854, which is 2.986.
We doing it?
Yes. Except that which would be left with all of them. We're trying to subtract all the areas in the triangle and R.
One common mistake would be that somebody would think that you don't have to split it in half and you can just do it like y2 minus y1, but you actually have to split it in half, so you have a function on the top and a function on the bottom.
So for this part, we had to find what the cross sections areas would be. So in order to do that, we knew the area of a square would be the sides squared. So that's where these two parts came from. And then for the integral, the lower limit is 1 in the problem. And the intersection is 3.693. And then that's the upper limit. Then for the next one, that becomes the lower limit, and 5 becomes the upper limit. Some common mistakes that, points. So points are distributed by the correct intervals for the integral and then the correct integrands. And then common mistakes would be one might mess up the intervals and make, since 3.9693 was on the top here, they'll make that the upper limit on the bottom too, but that you can't do that. One also might square just the x when the 5 minus x instead of squaring the entire problem.
So problem number C asks us to use a horizontal line y equals k, which divides R into two regions of equal area. And using this line, we have to write but not solve an equation involving one or more integrals whose solution gives the value of k. So to start this problem, we realized that it's because k is dividing it into two, whatever equation we're finding should equal the area of R divided by 2. So to find this, we realize that we can't exactly do it, or it doesn't make as much sense to look at it on the x-axis. So we flipped it around to the y-axis and used the interval of 0 to k. So that's where we got this limit from. And then because we did that, we had to change the equations.
Yeah, in order to get this, we basically just got the normal functions, which is like y equals 5 minus x, and then we set it into terms of x by doing that. And then the other one was a natural log of x, and to do that we just did e to the y here and e to the ln x, and that just crossed out and it made x equals ey, e to the y. And so the reason that it's in this order is because this right here is 5 minus y, or y equals 5 minus x, and you're subtracting this from this, so it's 5 minus y minus e to the y, whatever.
So the point distributions are basically, you get 1 point for the limit, having the correct 0 to k, 1 point for the integrand, having this correct in terms of y and everything, and then 1 point for the entire equation being correct, where you have the area divided by 2 equals this integral.
Some common mistakes are that some people don't like set it as like onto the y-axis, so they don't set these equal to in terms of x, and some people put this in the wrong order. Yep.